Okay, we are going to now look at examples that involve collecting like terms before we have to start moving things around and solving, right? So if we look at our first example here, okay, we've got 3x plus 5 minus 7x equals 21. Now, the whole idea of when you solve an algebraic equation is that you want your variables on one side. I'm going to make this smaller here. You want your variables on one side, and then you want just your numbers on the other. And by numbers, I mean the constants, right? So the constants are the ones that aren't attached to any letters. They don't have any variables on them. Those are called constants. I just call them numbers because I think that's easier sometimes. So variables on one side, your constants on the other side. Okay, so if I look at this, I've got two variables over here, and I've got one constant also in the mix, and then I have a constant over here. So when you think about how to move this, it's like separating Legos. It's like you want your red Legos here, and then you want your blue Legos over here, right? And so same thing. I want my variables on one side. I want your constants on the other. So just look at this and think to yourself, well, what does it make more sense to move, right? Well, it would make a lot more sense to move this, right, than it does these. Now, the thing about collecting like terms is collecting like terms makes it possible for us to move things in a more efficient way, right? And so in this example, I'll show you how that works. But so for this one, I actually can collect some like terms before we start moving things around. And I have a 3x here, I have a positive 3x, and I have a negative 7x. So I'm going to add those up, right? 3x and negative 7x, and that gives me negative 4x, right? So I get negative 4x, and then we'll use green for our numbers. We have plus 5 equals 21, all right? And so now I've got my variables collected. They're already on this side, right? I got negative 4 of them, and then I've got a number here and I've got a number here. So I've got a constant and a constant. So it would make the most sense to move this over there because then everything's separated, right? So that's what I'm going to do. I'm going to subtract 5 from both sides, and that is going to give me negative 4x equals 16, because 21 minus 5 is 16. 21 plus negative 5 is 16. Different ways to think about it. So now we're going to do what we've done all along, which is you always, when you want to get x by itself, right, you divide by whatever is being multiplied by it. Well, it's being multiplied by negative 4, so we will divide by negative 4, right? We'll divide both sides by negative 4, and then you are going to get x is equal to, well, 16 divided by 4 is 4, and then a positive, which 16 is positive, divided by negative gives you a negative because it follows the same rules as this. All right, so that's how problems like that work. Okay, now when you have a problem like this over here, right, we've got all kinds of stuff going on, right? We've got a number here, and we've got a number here, and we've got a number here, and then we look at our variables. We've got a variable there, and we've got a variable here. And you'll notice that when I underline these, I'm including the sign to the left of these, and you have to always do that. And if it doesn't have a sign to the left of it, like this one or this one, and when it's the leading number, right, then it's positive. If there's nothing in front of it, you just assume that it's positive. And so here's what I got, right? So let's just rewrite this. So I have 8 minus 9, and then I have minus 13x plus 4x, and then we'll say equals 26, okay? Now, I'm looking at this and I'm thinking, okay, there's a number here, there's two variables here, there's two numbers here. If I move this over here, that means that I'm going to also have to move this and this on the other side. Okay, so it would make more sense to just move two things. Just move the 8 and the negative 9. Now I want to show you something. I want to show you If we decide to do that without collecting like terms, here's what we'd have to do. We'd have to go minus 8, right? And then we'd get 18. And then we'd have to go plus 9. And then we get 27, right? Now, it makes a lot more sense in my mind, and I hope in your mind, to just say that, okay, well, I know that I have 8 and negative 9. Add those up, you get negative 1. And then add up the red here, your numbers, right? Your variables, and you get minus 9x, and then is equal to 26. To me, this is a lot cleaner. It's a lot easier to work with. Yeah, it just makes more sense. Okay, so we are now going to add 1 to both sides, because you're always doing the opposite, right? So if it's a negative 1, you're going to add plus 1, all right? So add 1, you get 27, and that is equal to negative 9x, right? Because the reason it's equal to negative 9x is because that's what's left. The numbers are now off the equation, right? So we got negative 9 from adding these two up right there, and then we just bring that down. And so now the last step is to divide by negative 9 everything, all right? You divide the entire equation by whatever the coefficient on the variable is. And so then that's going to give me x is equal to 27 divided by 9 is 3. Positive divided by negative is negative 3, right? And I could even add, I could put this in and see how it works, right? So I could say, okay, 8 minus 13 times negative 3 plus 4 times negative 3 minus 9 equals 26. Well, it looks like a lot, but it's not that bad. 13 times 3 is 39. Negative times negative is positive, so we have 8 plus 39 minus 12 minus 9 equals 26. Well, let's just go left or right. 8 and 39 make 47, right? 47 minus 12 is 35, and 35 minus 9 is actually 26. And so we get an equality. So that is how these work, my friend. All right. Next video, we will look at throwing some other things at you.